So we have been studying how to solve quadratic equations, and the methods we have studied so far are using square roots, and then we have computing the square, computing the square, okay. And then we also had factoring and graphing, factoring and graphing. So our last method is by using the quadratic formula. And the good thing about this formula is that it works for all types. So unlike these first three methods that work faster and efficiently for specific types of quadratic equations, the quadratic formula can be used for any type. It could be a quadratic equation of the form ax squared plus c equal to 0, or it could be of the form ax squared plus bx plus c is equal to 0. I also taught you how to find the discriminant, right? Because the discriminant tells you how many possible x-intercepts an equation would have. In addition to telling you how many x-intercepts it has, I think it also gives you a very good insight as to what method you are going to use when you're solving the quadratic equation. So if the discriminant is positive, meaning it has two real solutions, then I would probably use factoring or graphing to solve the equation. So now let's take a look at how to use the quadratic formula. First, you have to make sure that it is written in standard form. So it has to be arranged from, the highest degree to the lowest degree. And then after that, in the same way as we did in the discriminant, you have to find the values of a, b, and c and identify them correctly. And remember, you have to take their signs with it, because those are the numbers that you will substitute in the formula. So the formula is x is equal to opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And once you have substituted the values, you simplify the answers. So I'm going to explain how we got these answers by working it out over here. So earlier we said that the discriminant of this problem is positive. The result was 1. The value was 1, so it's greater than 0. So if the discriminant is greater than 0, greater than 0, that would give you an idea that, oh yeah, maybe factoring would work. Well, let's see. If we do factor this equation by using the x method, -5 goes on top, 6 goes at the bottom. So the two numbers that multiply to 6 are -2 and -3. I had to make them negative so they would add up to -5. Now since you have a constant a, which is equal to 2, you have to divide this by 2. So this results to -1, right? And that's -3/2. So when you write the factored form, it's x minus 1, and then 2x minus 3 is equal to 0. Remember the bottoms up rule that we studied before. So by using the zero product property, x is equal to 1, and x is equal to 3 over 2. So we haven't used the quadratic formula yet. We did it by factoring. And why did we do it by factoring? Because we figured out earlier that the discriminant is positive, so it has two real roots. In other words, it has two x-intercepts. There you go. Will we get the same result if we use the quadratic formula? Well, let's see. So identify first the values of a, b, and c in the standard form. So your a is 2, your b is -5, and your c is 3. So substituting in the formula, x is equal to opposite of b plus or minus the root of b squared minus 4ac all over 2a. So substituting the values, opposite of b, since your b is negative 5, you get the opposite of that, it will become positive 5, plus or minus square root of, you square your negative 5, so b squared is negative 5 squared minus 4, your a is 2, and your c is 3. Let's extend this one. All over 2 times 2. So simplifying further, we get 5 plus or minus root of negative 5 squared is 25, minus 4 times 2 is 8 times 3 is 24. Now take note that this is the same result that we got when we computed for the discriminant. And then 2 times 2 is 4. So this quantity here inside the radical is actually the discriminant. So x is equal to 5 plus or minus 1, because 25 minus 4 is 1. If you get the square root of that, you still get 1 over 4. So now let's simplify your answer. Well, this can be broken down into x is equal to 5 plus 1 over 4, which is 6 over 4. If you reduce that, you'll get 3 halves. Then the other possible answer is x is equal to 5 minus 1 over 4. You get 4 over 4, which is equal to 1. So the answers here are 1 and 3 halves, which are the same as the values that we got here when we factored. So I think it's good that you saw, the same equation solved in 2 different ways. The quadratic formula works for all, but the factoring method definitely only works for quadratic equations that are factorable. So there are advantages and disadvantages in using each method. Okay, so that's an example on how to use the quadratic formula. Let's look at another one in the next slide. We also saw number 2 earlier when we were, calculating the discriminant. So just to give you an overview, we got the discriminant of number 2 to be positive. So it's 21 if I remember it right. So it has 2 real solutions. Now let's solve it by using the quadratic formula. So the value of a is 1/2. The value of b is 1. So it's the coefficient of x. So 1x. So b is 1. And then the value of your c is negative 10. So writing down the formula, x is equal to opposite of b plus or minus the radical of b squared minus 4ac all over 2a. So x is equal to opposite of b. Your b is positive 1, so that means change it to negative 1. Plus or minus the square root of, so if you square the b, 1 times 1, that's equal to 1. Minus 4, your a is 1/2, and your c is negative 10. So all over 2 times 1/2. So x is equal to negative 1 plus or minus the square root of, so the discriminant we got earlier was 21, right? Because 4 times 1/2 is 2. 2 times negative 10 is negative 20, but it has another negative here. So 1 plus 21. So this will be negative 1 plus or minus radical 21. And then at the bottom is 2 times 1/2 is just equal to 1. So that means our answers are negative 1 plus or minus radical 21, because the denominator is just 1. So what we're going to do if you want to change this to decimal is, get the square root of 21 in a calculator and find the two possible solutions. So let me get my calculator and do that. So we want to get square root of 21. So if you round that off to the nearest tens, square root of 21 is approximately 4.6. So that means x is equal to -1 plus 4.6, or x is equal to -1 minus 4.6. So the two possible answers are going to be 3.6 and -5.6. So those are the two possible solutions to this quadratic equation. Alright, so now it's your turn. Go ahead and go back to Schoology so you can do the practice for using quadratic formula. So when does a quadratic equation have like no solution at all, or when does it have no x-intercept? So to illustrate that, I'm going to use this example over here. Identifying the values of a, you get a is 6, b is 2. This is not arranged in standard form, so you have to move -1 over to the other side, and you will get 6x squared plus 2x minus 1, well, plus 1 rather, is equal to 0. So then your c is positive 1, not -1, because we moved it over. So again, a is 6, b is 2, and then c is positive 1. So substituting into the formula, x is equal to opposite of b, so opposite of 2 is -2, plus or minus the square root of b squared, so that's 2 squared, minus 4 times a is 6, times c is 1, all over 2 times 6. So simplifying that, we get -2 plus or minus 2 squared is 4. Now 4 times 6 is 24 times 1 is 24. So this is minus 24. And then all over 12. Now here you get x is equal to -2 plus or minus 4 minus 24 is -20. All over 12. So since the radicand here is negative, the number under the radical sign is negative, so it means that the equation has no solution. So the equation has no real solution. Okay. So I say it has no real solution because when you go to Algebra 2, you will be studying some techniques on how to, simplify radicals that have negative signs. So in that case, you will be looking for, the solutions of this equation, but they are not real numbers, so they will be complex numbers. So for now, in Algebra 1, we're going to say the equation has no real solution.